Welcome everyone to our podcast today. We have with us Lucy Foster-Bowen from Joseph Ash Galvanizers. Welcome, Lucy.
Thank you for having me.
Yeah, no problem. Thanks for coming. So I suppose we'll get going then. So you are an expert in galvanizing.
Apparently so.
So how long have you been in the industry?
I've been working for Joseph Ash for 5 years, but galvanizing has been around for many hundreds of years.
Yeah.
So I'd like to talk a little bit about that today, because galvanizing is something that everybody will experience in their lives, whether it's directly or indirectly. We will pass a lamppost or a fence or some kind of security, and that will all have zinc on it. So whether you notice it or not, it's definitely involved in such a large part of everybody's lives. So it's something that we offer that a lot of our customers like yourselves are aware of, but also something that we can offer more education on in terms of when people are specifying, they might want to go for a galvanized finish because it's going to prolong the life of their steel. We'll talk a little bit about that today.
Yeah, no, definitely. Okay, well, on that basis then, I suppose if we could maybe talk about the origins of galvanizing, how it come about, and I'm sure you know a bit about that.
Well, galvanizing's been around for hundreds of years.
Literally hundreds,
which is very interesting. It goes right back to the 1700s, when it was discovered that a zinc coating could be obtained on iron by immersion in molten zinc. And in France they use that a lot on household utensils, and the origins really start way back then. And then going into the 1800s, different patents were taken out for processes of coating steel with zinc, and the process was named galvanizing. And that's where we get the name from. The spelling is somewhat different dependent on where you are. We spell it with a Z. Some people choose to spell it with an S, but we are very much in the Americanized camp of using galvanizing with a Z. Galvanizing's been used in this country since the 1800s, and the first use of galvanized corrugated iron was believed to have been in Pembroke Docks back in 1844.
Wow,
we've been seeing galvanizing around for many, many years. By 1850, the British galvanizing industry were using 10,000 tons of zinc per year. So it certainly has origins way back when. Today, if we look around us, like I said before, there is galvanizing on everything that we see. It's on lampposts, it's on fences and security products, it's on drain covers. Also a lot of things that you wouldn't instantly recognise as being galvanized because they're powder coated. So somebody's garden gates, they're a nice shiny black, probably galvanized underneath. So it's used in everyday life, a lot in construction, also a lot for agriculture, and really low-key things like an individual gate or some fencing.
Is it generally, would you say, anything external that's metal?
Yeah, absolutely.
Is it what should be galvanized? Would you say anything as a general rule?
If you want to prolong the life of steel, you should get it galvanized, because as soon as steel is invited into the atmosphere, it will start to decay. And we'll talk about life expectancy a little bit later, because I think that's really important with specifying galvanizing as an additional cost to customers, because people might wonder why it's to be galvanized and what benefits they're going to get from that. So it's everywhere around us, really. I mean, good old Joseph Ash was founded in 1857 by the son of a chemist in Birmingham. And so
Wow, is that old?
Yeah, absolutely. Right. So we owe a lot of what we're doing today to history, and we do delve a lot into pre-treatment processes and how we treat metal before we galvanise it. But the process is very similar.
Could you go so on that basis? What are there set processes in galvanizing? Can it be different depending on the company? You know, do each company have their own process?
Absolutely.
Or is it generally just there is a certain way you have to do it?
The process will remain very similar depending on whichever galvanizer you go to. Every galvanizer, whether it's Joseph Ash or a competitor, will have a different bath chemistry dependent on their bath setup, which will remain a closely guarded secret. Some people have different metals within there to promote different things and the ways it moves and things like that. So every galvanizer uses the same principles but has their own finite details.
Okay. So some might be shinier for more cosmetic purposes, for example.
Back in the day, galvanizing was seen as not an aesthetic finish. It was something that was done to prolong the life of steel, and that was the end of that.
That was its purpose
the
only. The
appearance didn't really matter, as long as we meet the standards required of us. Nowadays, customers want to visualise something that's absolutely brilliant and shiny and free of lumps and bumps, and it all looks fantastic in order to present to their customers. Now, it's taken a little while, I think, for people to get on board with that idea of aesthetics, but it's incredibly important because we all know as a consumer, you want your product to look good when you're purchasing it.
Exactly. And especially if it's a high value product, which is what the products we sell at the Galvans are of high value. You can't be, you can argue still doing the job.
Yeah.
But if you're paying that money for something, you want it to at least, if it looks nice, it helps a bit, doesn't it?
Absolutely. We're very proud of our standards in terms of how we present work that we give back to customers. There's a number of reasons why the quality should be good, and there's a number of reasons how we can ensure that it is good. Firstly, we galvanise steel. Steel comes from many different sources and many different factories, and people treat that steel before it gets to us in a lot of different ways. So we're looking to make sure that piece of material is as clean as possible before we introduce it to zinc. So we put it through a pre-treatment process whereby we take off as much of the grime, of the grease, anything that we can possibly think that's going to hinder us in terms of presenting you best quality product. And so our pre-treatment processes are where we enable the guys who are going to work on the items to have a perfectly clean piece of steel in order to present to the zinc bath. Zinc has the ability to protect steel against corrosion. That's its purpose. That's why we use it, and thus improve the lifespan. So we want to make sure that when we introduce the work to the zinc bath, we're going to give it the best chance of lasting as long as possible. We do that by degreasing the material. So it's a little bit like fairy liquid for steel. So we're going to give it a good soapy wash. We make sure it's nice and clean, and then we chemically clean it with acid. We do that. Every galvanizer does that. And we'll give it a rinse, make sure there's no acid on it, and then we give it an immersion in a flux tank. So what we will do is we immerse it in the flux solution, which will improve the surface area of the product, so it will rough it up.
Rough up it,
yourself, a lot of the products that we galvanise are really smooth, so we want to be able to increase the surface area so that when we introduce it to the bath, there's a better reaction that's going to be happening between the zinc and the steel.
I guess if you didn't do that, it wouldn't stick as much.
It gives us the ability to know that the quality we're going to give back to the customer is going to be the best we can possibly achieve. When we do get to the zinc bath, I think it's quite important to point out to some people who might be listening to this today is that there's no demarcation between steel and zinc. We're not coating the steel, whereas a lot of other finishes will be a coated finish. There's a bonded coated form between the steel and the zinc. So the steel is the zinc is the steel.
Yeah, it like replaces.
Absolutely, it's a gradual transition through a series of alloy layers which provide the bond. So once you've galvanised something, you can't pick it off. It's there. It's part of the.
And that leads. Well, that's the other something like cathodic reaction. That's all that stuff, then, isn't it? Where it's kind of self-healing. I'm guessing it's all linked to that. But that's for another day.
I wanted to talk a little bit about something which I know you're going to ask me about, which is the life expectancy.
If we could, because I've worked in the construction industry for 13, 14 years now, and it's always been a question: how long can you guarantee? And it's just, the number 25 years is bandied around quite a bit. But I've always thought, who's policing that? Like in 25 years. Is someone got a date in their diary, set an alarm?
Yeah, make
so
sure
let's
it's
check
still
that's still
there,
there.
Hasn't rusted away.
So that's what baffles me, and it seems like there isn't any proper structure. There's no what are the rules? Should there be rules?
There are rules. Firstly, the life expectancy of anything is going to be dependent upon the environmental factors. So if we are going to install a fence in a very inland dry area, it's going to react differently to the atmosphere to if we put it by the sea. Because obviously the marine environment will attack the metal more and the salt spray, etc. However, we have a brilliant standard. We are governed by ISO 14061, which is the galvanizing standard. And that tells us, as galvanizers, all galvanizers, exactly how much zinc we need to put on your product based on the thickness of that product to enable it to last for X.
Okay.
So
would they need to say, right, we need this thickness of steel to last 30 years, and
some
then you...
customers do. Some customers will come along and they will specify something, and they will say, it's going to be in a marine environment. What can you do to help us? And we will give them advice. If you want to have a better galvanised coating, insofar as a thicker coating, you might want to shot blast that material. You might want to provide material with a high silicon content, because a high silicon content will encourage a bigger reaction when the steel is introduced to the zinc bath.
Right, okay.
There is a guide which is provided by the Galvanisers Association, of which many galvanisers are members, including us, which categorises the average micron loss per year and the average lifespans of products. Now, a micron is how we measure the coating on a product.
Yeah.
So
the thickness.
Yeah, absolutely. A micron is 1,000th of a millimetre, so it's teeny weeny. The average human hair is 50 mil. So 50 microns, sorry.
Wow.
I'll say that again. The average human hair is 50 microns. So we can see that with very, very little protection, we can give your products a guarantee, not a guarantee, we can give your products a lifespan of many, many years. Now, most dry inland situations, the loss of microns per year will be less than 1. So we can say, if your steel is greater than 1.5 mil and less than 3 mil, we have to put on 55 microns as an average. So that is required of us by the galvanising standard, and we will adhere to that. Now,
why 55?
Because that is the determination given by the Galvanising Association, who put together this standard, that will give an adequate lifespan.
Which is?
Well, there is a brilliant table, which I'm not even going to show you because it's very in-depth. It's the ISO 14713, which is a typical lifespan of a product in an environmental atmosphere, and it categorises the corrosive category of where a product is going, which goes back to my original point. It depends where you're going to put it.
Is this the C2, C3, C4 categories?
You're right, completely right. So is it dry and cold? Is it temperate? Is it subtropical? So we can have a look at that. We can cross-reference that with our corrosion map, and we can see in X amount of years, you are probably going to have to do some maintenance on your gate. Okay. Now, if we're looking at 1 micron per year and your steel is super duper thin and we're going to give it 55 microns, we're going to be looking at 55 years.
Okay.
So,
but it's still, there's not a guarantee though.
There can't be a guarantee because it does depend on where the product actually goes and how it's used, because a lot of people will install a beautiful fence and look after it and take care of it, but then somebody will install a beautiful fence and it will be neglected.
Yes.
It will be somewhere really damp. It won't be looked at. It will be covered in plants, and then that's not going to react in the same way to the beautifully clean vents that Mr. Jones is
sure.
once a year.
Okay.
It's difficult for us to give a guarantee, and we'll only ever give a guide. However, the thicker the steel, the more zinc we're going to put on it, because the bigger the reaction's going to be. So if we want to guarantee something, we can look at using slightly thicker steel. If we shot blast it, we're going to increase the surface area of that steel. Yeah. So the reaction is going to be greater, therefore we're going to get more zinc on. And also if we use a high silicon content steel, again, silicon is an impurity in steel which does promote a bigger reaction, so we can draw more zinc to the product. So if somebody comes along to say it's a marine environment, need 120 microns, we will give them all of that advice, and then we can also prolong the dip time very slightly, because the reaction is finite. It will stop. We can't leave it in the bath for 3 hours.
Yes.
After a certain amount of minutes, there will be no more reaction.
You can't get any more on it.
Absolutely.
Yeah, there is that. They were like, can't you just leave it in the bath a bit longer to get it? I'm like, I don't think it works like that.
No, it doesn't. But the galvanising standard is brilliant because it gives us the expectation of what we will put on your steel when you give it to us. We are governed by that. Okay. If we galvanise a product and we think that it hasn't picked up enough in terms of zinc, we should look at reworking that product. Likewise, if we think that something's got a hell of a lot of microns on it, we should again talk to that customer to make sure their steel that they're being supplied with is what they're being told they're actually getting. Because some things very, very high pickup steel, and if customer wants a brilliant aesthetic shiny piece of metal and it's full of silicon, they're probably going to get a really dull piece of metal and perhaps not understand why that's the case.
So it isn't a simple question then, is it? It can vary, depends where it is, it depends what they're using it for, depends what the profile is.
Absolutely.
So all of those Okay, no, that's interesting. Well, that's good. That really, I don't even need to answer the question then. It's something I can say. Yeah, well, you need to find out. It's really what they want.
Yeah,
what do you need it to do? Yeah. And then we'll find a solution.
Speak to your customers and ask your customers where it's going, what they're going to need it to do, and how long they want the lifespan to be. And then we can give them guidance on how thick their steel should be.
Yeah. It's usually to their retirement age.
Yeah, absolutely.
It's not their problem then.
But most things that we galvanise, we won't have to worry about in our lifetime.
Yeah.
You know, and like we said earlier, a lot of things that we galvanise, are they still going to be there in as many years as it takes for us to give to life to first maintenance of those products? So,
you still don't know, do you? It's you can't guarantee it.
Absolutely.
So I know a little bit about galvanizing, and I believe there can be an issue with ventilating galv, and if you don't ventilate it and building up of pressures and whatnot. As I'm guessing, again, you know a bit more about that. Is that something which isn't really talked about? Is it something which should be talked about more of an awareness on it?
Venting and draining and galvanising is probably one of the most important things that we should speak about with every single customer, whether they have a straightforward two-dimensional product or not. The reason we talk about venting and draining is because we are going to introduce products into a very hot, very pressurised environment. So with a two-dimensional product, that's going to be dipped very straightforward. It needs to have a hanging hole and not a lot else, because it's going to go in the zinc bath, come out the zinc bath, and that's quite simple. Customers who have complex designs, frames, gates, tubular work, anything that is three-dimensional that's going to suggest to us that it's going to have an airlock or going to hold air in any certain area, we really should talk to them about where the best placement of holes is for them. Because what we look to do is we want to allow air to escape from the product, zinc to enter the product. Firstly, to make sure that we cover all the areas inside and out, because obviously we're not going to galvanise the outside of a product. But secondly, when we introduce air into a zinc bath, the zinc bath's around 450 degrees, that air is going to become superheated. If it hasn't got anywhere to go, it's going to explode through a weld or a plate or the path of least resistance. So
the weakest point.
We absolutely have to encourage and educate our customers insofar as adding holes to allow that to happen, to keep our employees safe. And to make sure also, I mean, that's the most important thing, is to keep everybody safe. But secondly, the more they think about drainage holes and venting holes, the better quality they're going to get. Because if they put the holes in the right places, they're not going to have any zinc runs, they're not going to have any zinc build-up. People pay for zinc by the ton, so we want to put as little as possible on for you guys, what's meeting the standard. So we don't want to have half a box section post full of zinc. It's not in your interest, it's certainly not in ours. So we work hard with people to make sure that the design for galvanising is something that they think about before the piece comes to us. Otherwise,
because it could get to you and you're like, hang on a minute, I can't actually galv this, there's no holes in it.
100%. And it does happen. It will get to us and we will have a look at how we're going to hang it. Everything is unique. So everything is hung in a slightly different way, and that will vary from galvaniser to galvaniser. And if it's not got the correct holes in, it delays our customers, it delays us, and then someone's got to, wing it along to site and put some holes in. And if that's 15 mil steel, it'll take someone 10 minutes. So safety is the first and most important aspect. But secondly, we want to be able to work with our customers and our customers' customers to make sure they get the best of us. And we do that by sitting down with them, looking at their drawings and advising them how we think we're going to put that product in the bath and how we think they should ventilate it. Sometimes you have to work together because it's not always possible, especially if there's a very, very specified use for the product. Maybe if it's going to nuclear. They don't want to be putting holes in it.
Okay. So what would you do then?
Talk and talk again.
Come up with a solution.
There is normally a solution we can come to. But sometimes it's quite time consuming because obviously the drawings have been signed off somewhere down the line. So the whole point of venting and drainage and getting it right with customers is that we eliminate airlocks, we eliminate zinc traps, we promote the flow of zinc over product, we keep our operatives safe, and we promote better quality to customers.
So, if that explosion that you say, would that happen as it's coming out of the bath? Is it days after? When would that happen?
It would happen at the bath.
It would happen there and then.
So
Okay.
if you consider that we have operatives, as all galvanisers do, who work the bath to make sure that the product has been immersed into the zinc, and then they skim back the bath, etc., etc. If they notice that anything doesn't look quite right, as soon as that jig is going down, it's pulled. But we don't want to get to that stage, which is why I would say every galvaniser has multiple step checks to make sure that work comes in, the guys in the yard have a look at it, the supervisors of the shift have a look at it, the guys who are hanging it on the line have a look at it. And if anybody thinks this isn't quite right, we want to see it then. But the whole purpose of one of the main purposes of my job is that I'll see people and say, I think you should do this before it's even constructed, before fabrication even begins, because then it's going to solve so many problems. Now, if, God forbid, anything gets to the bath and it's not vented properly, it can result in loss of life. You know, and it absolutely has done in this industry, which is terrifying. And you don't
go to work, do you?
Absolutely. We do a lot with. We have a technical team, and we do a lot with them insofar as if customers feel like they want to be more educated on where they should put venting and hanging holes, we will send out our technical team who will present to them and say, this is what can happen. This is what we can do to prevent it. Let's talk about your particular product, and they will advise. And that's a service that we can offer for nothing, because we would rather.
It's in your interest, isn't it?
It's education.
Exactly.
It's absolutely education.
No, that's interesting. I wasn't really aware of that. Okay, so obviously it's quite like I said, it's been around for hundreds and hundreds of years. It's quite a traditional way of coating products. But can you see there being any changes in the way it's been done? Do you think there's, I don't know, quicker processes, a better coating? I don't know, what's your view on?
Firstly, I'm here to say there is no better coating than galvanizing. We will always come up against other finishes. There will always be people that just want to powder coat without galvanizing first, and that's okay if that's on them. But you've probably seen yourself, you'll drive by somewhere and you'll see the paint flaking off a product, and you can see just the black steel underneath. Well, obviously, the paint flakes off and the black steel underneath, you've got to take it right back to basics to be able to repair it. Galvanise, you can take it back to the gal steel, and there will be no degradation on that piece.
So you can repaint it or whatever.
Absolutely, you can clean it and repaint it. There will always be other finishes that people want to consider. Going back to how we talked about aesthetics, people sometimes want a chromia or a stainless steel finish from a galvanised product. Now, I understand that. However, it is a gal finish, and we must expect that the coating won't be as uniform as chrome or stainless steel because of the chemistry behind that. So we're always up against those things. Now, stainless steel is very expensive. Not a lot of customers want to pay for that. Galvanising is quite reasonable. Paint, the cost of painting compared to the cost of galvanising, paint has risen quite exponentially. So that's still quite an expensive thing. Some of our customers have mentioned pre-gal products, which is a product that you can buy that is already galvanised. It's a nice smooth finish. However, for your intended purpose, that might be okay, but it will contain such a low level of microns that it really isn't going to offer any of the protection in terms of corrosion that we can give you following the galvanising standards. So
it's predominantly internal use, that would be, wouldn't it? That's where we would supply pre-gal.
Absolutely. So we wouldn't promote any of those things, but we're always going to come up against those things, and that's absolutely fine. But the galvanised finish is just going to give you the galvanised finish is just going to give you corrosion protection for such a long time in compared to other things. Now, in terms of infrastructure, social housing, as those things increase, which they absolutely will over the next decade or two, the requirement for galvanised steel is going to be more prevalent, I think. Ultimately, it leads to a lower maintenance budget because the galvanised steel is not going to have to be messed with after a couple of years, and it can just be left alone. Now, we talk about the environmental impacts of what we do, and if we look at galvanising for a circular economy, and we look at the environmental impact of galvanising, it's really environmentally friendly in terms of its sustainability.
Oh, really? Okay.
Because we can galvanise it, and it's going to last for an awfully long time.
Yeah, I suppose,
You're not going to have to think about your frame that you've put under your house because you know it's going to be there for the lifetime of the house, and that's why you've had it galvanised.
Yeah.
It's durable and it's tough. It's going to last. You can bash it around. It's not going to chip. It's going to be very durable. And it's quite cost effective insofar as I think people think galvanising is a lot more expensive than it is. People generally charge by the ton, dependent on the product. If we look at the lifespan of the product versus the cost, it's quite a teeny-weeny amount of the entire project.
Yeah, sure.
If you look at the galvanising cost on structure for a housing, for example.
Yeah. But I suppose the thing is, it depends on, again, it could be, if someone's only got the maintenance contract for 5 years, so we have it still last year, we'll just do a bit pre-galving because, and so it depends, if they need to maintain it for 30 years, and you get that sometimes, so people cut corners because like in a few years it's not my problem anyway, so
absolutely understand
cheap,
that.
cheerful.
Sure.
Not good, but I understand why.
A lot of people, I suppose, come along to us and ask us why we should galvanise things. Then we're always going to tell them too. That's absolutely what we're in the business of doing. But we are really keen to promote the ethics behind galvanising and the environmental impact comparatively to other processes that they can pick at the moment.
And we should be talking about stuff like that. We have to, I suppose. We've got to, haven't we? Everyone's got to do something.
I fully agree. The environmental impact of everything we do is so super important, and I think historically people have thought that factories, places that galvanise, places that fabricate, very dirty, horrible places, but
they are. Where
I work in the heart of the Black Country, we are the lowest risk galvaniser in the country. We were downgraded to low risk by our local authority. The reason for that is the background work we've done to improve our environmental credentials, and I think it's really important for any business to give that some consideration now, because when customers are specifying, many years ago it would have been the best price wins or the quickest delivery wins. Now it's going to be the environmental impact, the ethics and the social value that win those contracts. And we're really aligned.
You get inspected and things, don't you? Have audits, so they want to see health and safety measures and things like that.
Absolutely. So we're really trying to align ourselves with those social values and that impact and those good ethics, because that's what will give our customers confidence to use us, and that's why we promote galvanising, because we can give them the information they're going to need, and they might not need it right now, but in 5 years' time they will absolutely have to specify why using a gal finish is going to be more environmentally friendly or better than another finish. And so we're working on that right now, so we're able to provide them with good intel for their customers. But we try and make it as simple as possible for customers. I think.
Well, that's good. Well, I think that's thank you for today. That was I think I've learnt something. I didn't realise it was that interesting, galvanising.
It's very interesting.
And particularly with the holes and the that was I'd heard about it a little bit, but I wasn't aware of how dangerous that can be.
Very safety critical. I mean, galvanising is thrilling, and it might sound like I'm not being entirely serious, but it's super thrilling. And when people come to visit us on site, as you've been.
Oh, it's amazing to see the process.
It's very exciting.
It is,
insofar as how we take something very straightforward and make it so amazingly long-lasting. So if any of your customers want to come and see us, or your customers' customers, we're more than welcome to show people around, because that's what we do. Very proud of what we've got.
Brilliant.
Thank you.
Okay, thanks, Lucy. Thanks for today.
Thank you.